Hello and welcome to day 12 of Advent of Code 2024. So in this video we have a map, something like this, where all the letters on the same group are plants of the same group. So if we have a map like this, it can be translated to something like this. Now we want to provide some fence around all the plants of the same type. So something like this. So we need to basically walk through this map or grid and find all the plants of the same group and then provide the fence around them. The thing that the puzzle wants from us is for each of these areas we find the number of the plants inside, or basically the area of this portion of the map, multiplied by the perimeter. Now the perimeter for example this one would be like 1, 2, 3, 4 and then 4 on the bottom and then 2 on the sides. It would be 10 times 4 number of the A's inside. It would be 40, and they would do it for all the plants in the map and then add them together. So there are lots of examples here. So this is a bigger example. So for example, for plant R, it would be like these ones and then this one and then this. So it's a little bit complicated here, but we need to find the area and perimeter. To solve this, let me first show you the mind process. So we have a map, something like this, and let's say for example these ones are in the same group. Okay, now we start from here obviously and we would go through the map. When we get to a cell, first we mark it as visited so that we don't calculate it again. So let's say this one is visited. Now from here I would take a look at all the neighbors for this specific cell. If the neighbor is from the same group, which in this case is, so we would add this to the stack to take a look at it later. If it's not, then we provide a line between the two. So in this case they are the same. We just add this to the stack. So our stack will be having 1 inside it. Then we look at the other. There is no plant here, so we provide a line. There is no plant to the left, provide a line. There is a plant but it's not the same, so we provide a line here. Now we go to the stack. Do we have anything to stack? Yes, we have this one in the stack. So we will pop this from the stack and mark it as visited. Now for this one we take a look at all the neighbors. This one is visited, we ignore it. This one is the same plant, so we push it to the stack, so our stack it remains 1, and this one is the same plant, so we add this to the stack as well. So these two are done with. We would take a look at this. We have visited this before, so we ignore it. We look at top, there is no plant, so it's not the same as this plant. We provide a line. We take a look at our stack again. We have 2 items in the stack, this one and this one. We will pick one. So for example, let's remove this. We pick this one, mark it as visited. Take a look at all the neighbors of this one. There is no plant on top, provide a line. This is different, provide a line. This is the same and it's not visited yet, so we add it to the stack. And this is the same and visited, so no line here. Now we have a stack of 2, which are these 2. We would pop 1, which is this one. We would take a look at the neighbors of this. This is already in the stack, ignore it. This one is not in the stack and the same plant, add it to the stack. This one is visited, we ignore it. This one is not the same plant, so we provide a line here. Now when they take a look at stack, let me mark this as visit as well. So we will pick one of them. So let's say we remove this one and we pick, for example, this one. Doesn't make any difference. which one we choose. So let's say that we would take this one, mark it as visited, look at the neighbors. This one and this one are dealt with. These two are remaining. They are not the same plan, so we provide 2 lines for these. And then the final one, which is this one. Remove it from the stack. Go here. The top one is dealt with. These 3 on the left, bottom, and right are not the same plan, so we provide 3 lines here. And this will show the perimeter for this part. Okay, so we have the perimeter. We know the area, which is the number of these values, because every time that we would visit them, we would add 1 to the area. So we know this is like 6, and then times the perimeter of this. So we were here, we would move to here, then this one. We have visited this, calculated this, we ignore it. We would go here, visited, calculated, ignore it. We would go here and do the rest of the calculation for this one and all the plans of the group of this one. And we would do this for the rest of the grid until we get to the very end. Okay, I hope this is clear now. So let's go to the code. For the part 1, just like always, we would split it by new line and map each one to the row splitted by empty string. So we would have a grid, just like the grid that we have here. And then I would get the rows and cols so that I don't use this every time in the code. And then I would have a visited, which is an array that will be filled with false. All these inputs, the same as size of this input, but all the cells are filled with false. And I would have some direction that would point to the different locations. So from here, top, left, bottom, and right. These are these ones. So for example, this one means that go to the right. This one means go to the left. This one means bottom, and this one means up. Now to the code. I want to keep the regions. So this is a region that we have here. For all the rows and columns, we need to go through all the items in the grid. So 2 for loops. And if this item that we want to take a look at is not visited, which is not in the beginning, we would say, okay, this plant or this char can be plant. It would be better to call it plant. This plant is this that we have here. So for example, if this was A, like this, then the char would be A. Okay, so we would get the char and we would process the region for that character or for that plant that is lying on the I and J position. And this process will send back a count, which is the area, and the perimeter for us that we would keep track of. So let's go to the process. Now, the process is the heart of this code. First, we would say, okay, the count is 0 and the perimeter is 0. We would create a stack, which is in the beginning, this very spot that we used for the process. Okay? And then, while there is something in the stack, which is this stack that we defined here, we would pop that from the stack here. If the thing that we popped from the stack is not inside, so if for example from here this is added to the stack, we would ignore it. If it's visited, we would ignore it. And if it's not the same plant, we would ignore it. So for all of these cases, we ignore that cell. And then if it's from the same type of the plant, we just say, okay, we are visiting this. So we say this is visited, and we add the count, which is the number of the areas. This can be called areas. Then for each of the directions, we would create a new cell. Now this cell will be using these directions for the x and y, and we would get the new x and y. Now, if this new cell that we created by these two values is not inside, or if it's not the same plant, we would add one to the perimeter, just like the thing that we did here, basically. Okay. Otherwise, we would check that if it's not visited yet, we just add it to the stack. So, for example, when we were here in the beginning, we would take a look at this and we see that, okay, we have not yet visited this, so we need to add it to the stack because it's from the same plant. And this will go on and go on until there is nothing left in the stack. And in the end, we just return the count and perimeter. And obviously, in the end, we need to just, for each of the regions that we found, multiply the count by the perimeter and add it to the previous value and return the final result. Okay, so for part 2, if we go here, let me remove all of this. For this part, the thing that we need to do is, when we have this perimeter around this shape, we need to consider this 1 instead of saying, okay, this has the perimeter of 3. In the previous example, it was like this, but now we are going to merge these all to 1. The same goes for here. Okay, so this is the thing that we need to do, and then count all these lines. So let me make it a little bit like different this time. So now if I say these are, let's say, blue. Now if we want to calculate all the sides of this, it would be like 1, then it would be like 1, then 2, then 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, so these will be the sides that we want to calculate for this shape. Now, how can we do that? In order to do that, I would take one of these cells, for example. Let's say we would take this one. Let me mark it different. Say this is like green. Now, for this one, I would take again at all the neighbors around it. If it's not the same, so either this is another plant or it's empty, we don't care. If it's not the same, we need to create a line here between these two, starting from this position to this position. Then let's say we would go to this one. Up to now, it's the same. Let's go to this one and mark this blue again. We go to this one, and we need to take a look at all the directions. Let's say we take a look at up, and there is not the same, so we need to create a line. But now the important part is that we already have another line in the same direction as this, which will end to the beginning of the next line. So we have these two lines, but this second line should be merged to the line before that. So when we want to create this line, we need to take a look at all the lines for this region and see if there is a line on the left that will end to the beginning of this line. Similarly, if there was a line, for example, here as well, we need to consider that one as well. So when we want to create a line, we need to take a look at the before and to the after of that line. If both of them are there, so this line is there, this line is there, we don't add the line. So we would remove this line, basically, and just connect these two to get a new line. Okay, but if, for example, only the left one was there, and we wanted to add this, then we wouldn't add this, we just extend this to here. This would be the new line. Similarly, if only this was there and we wanted to create a line from here to here, we would get this point and put it to here. Let me show you this in code, and then we would get to the fix that we need to do later on. So for part 2, all the parts with the is inside and everything is the same, just like the part 1. And we would do the same thing, but this time the process is a bit different. We don't count the perimeters, but we take care of the sides. And each side will have 4 values, the xy of the beginning and the xy of the end. Now again, just like part 1, we would put the xy into the stack, and while there is something in the stack, we would do some calculation. Again, this is the same as part 1. If it's not inside, or if it's not the same plant, or if it's not visited, we don't care about that. Otherwise, we add 1 to the count. Now for the side, which is the important part. Again, we get the for this I defined another thing for these directions. So I have changed the direction to be, say, R is this one, L, D, and U, and I would use these values in my code. So let's see. For all the directions, I would get dx and dy, which would again point to these values, this part, and I would create the new x and new y just like part 1. Now, if the thing that we are looking is not inside the grid, or it's not the same plant, we need to draw the line. Now it gets interesting. If we are looking at up, so if we are here and we are looking at up, we would say that this is like x is 1 and y is 4, right? So this one has the x, this is x0, this is x1, and this is 0, 1, 2, 3. So this is 1 and 3, so 1 and 3. Now we would take a look at the up. If it's not the same plant, we would need to draw a line from 1 and 3 from here to the next, which is 1 and 4. So this is 1 and 4, and this is 1 and 3. So we need to draw a line from 1, 3 to 1, 4. Okay? Now, we would take a look at the lines that we have already drawn for this region. And if there is a line that, for example, like this, that is starting from somewhere, it's horizontal, so it's 1, 1 to 1, 3. The line that we found is this, starts at this and ends at this. But the line that we want to draw starts at this and ends at this. So the old line can move from, instead of from here to here, can move from here to here. Okay? So this is only when there is something on the left. Let me do it for the right, and it would get more clear. So we were here, this was 1 and 3. This is 1 and 4. If we found a line from here, let's say to here, which is from 1 and 4 to, let's say, 1 and 8, we need to say, okay, I want to draw this line, but I have a line from 1, 4 to 1, 8. So instead of just adding this line, I would say I am extending this line from the left to here. So this would be from 1, 3 to 1, 8 instead. Okay? And similarly, if there are both lines available, so if we have this line and this line. So this is like from 1 1 to 1 3, and this is from 1 4 to, let's say, 1 7. Now I want to draw this line, so instead of these two lines I would have one line. So let's say I would remove this line and extend this to here. So this would go to here. So this is removed, and I would say the new line that we have is from here to here. This is similar for the bottom, for the left, and for the right. So in the code, I would take a look at U. I would take a look at all the sides and find the side that satisfy these rules. The number 2 is the current, the number 3 is Y, and the number 0 is Y. So let's say I would do it for 1, and it would be the same for the rest. So the line that I have is this one, 1 1 and 1 3. This is 0 1 2 and 3, and I want to draw from 1 3 to 1 4. So I need to find a line where this value, the current X, is the same as this. This one is the same as this one, and I want to consider the horizontal line. So this only should be, so this also should be 1 to make this horizontal. Otherwise we could merge this line, for example, with a line like this that we don't want to do. Okay, so I need to check these three values, this one, this one, this one, against these two. If that is the case, then we have something on the left. Similarly for the right, would be from here to here. So this is 1 4. This is, let's say, 1 and 9. I would check these two against these two, and this value against, again, this value. Okay, this is done here. The 0 should be this one, 1 should be the next, because we are like here 1 3, but we want to draw from 1 4, and the side 2 should be car X. Now if we found both of them, I would remove the right part, and on the left part the Y value would be the Y value of this. So again, I would remove this and put this point instead of this point. So this would go from 1 1 to 1 9. If we only find left, we just add 1 to the Y. So if only it was this, we would go from here to here. And if we want, and if we only found right, we would just move this value to the left. That one is done here. Otherwise, if it's not found, we just push this line to the regions. Similarly for the D, it's like this, the same logic. We just check against the lines before and after and do the calculation here, where here is where we would remove the after one. So we would slice all the sides up to that point, and one after that we would remove this right index. And similarly for the left, it would be like this. Again, the same procedure. And for the right, again the same procedure but with different indices. Okay, I wouldn't go into details here because this would make the video too long, and I don't want to do that. So this way we can find all the sides. Now this would work perfectly, but there is a very small problem here, and that is Let me remove all of these. So we would have this line, this line, and for this it would be like this. Okay, now the issue is that when I'm drawing this line here, I would see that this line is still here, so these two would be merged together and provide one line, but not these are like intersecting. So this line is intersecting this one, cutting these two, so we need to count these differently and these two differently. So here, instead of saying okay, from here to here is 1 and from here to here is 1, we need to say from here to here is 1 and from here to here is 1. So this is like 4 sides, but we counted it as 2 because we take a look at all of these lines and we merge them with the next one. So in the next one, we need to take a look at all the lines that have an intersect, and the intersect is not in the corner. So we ignore this line and this line that have a intersect on the top left. So only something like this. We need to find that, and if we found that, we would add 2 to the sides, because this one was 1 and 2, but we need to say 1, 2, 3, 4. Okay? So now we would create a function here, count middle intersection for that region, and if that is found, we would add it to the sides that we have. So how does this work? Now we say okay, the count is 0. We would check all the lines with the next line. So for this line, I would check this against all of these lines to see if this has an intersection with this. Now intersection would happen when this function happens. So line 1 will have these values, line 2 will have these values. If y1 is equal to y2 and x3 equals to x4 as described here, so line 1 is horizontal like this, and line 2 is vertical. So only in this case this can be intersecting, or the other way. Line 1 is vertical and line 2 is horizontal. So basically this. So if y1 and y2 are equal, and x1, x3 and x4 are, meaning that line 1 is horizontal like this and line 2 is vertical like this, then we can check the x value. If the x of 3, which is equal to x4, is between x1 and x2, so here we have this line and this line. So let's say this is x1 and y1, x1 and y1, this one x2 and y2, this is x3, y3, and this is x4, y4. Now if x3 is between x1 and x2 and y1 is between y3 and y4, these have intersection. Okay, so this is shown here. Again, similarly for the other way around, if y3 is between y1 and 1, 2, and x3 is between x3 and x4, then these are having an intersection. So we return true in these two cases, otherwise we return false. Now obviously if both are horizontal or both are vertical, they don't have any intersection, so we ignore that. And we basically add the value down here to the number of sides, and then we return it here, and the rest is the same. We just calculate these values and get to the final answer. So I hope you've enjoyed the video. If that's the case, don't forget to subscribe to the channel, and see you in the next one.